Hey friends, welcome to DCT Lab, and for obvious reasons, I am Mr.DCT. Have you ever wanted to make your own tiny world with rules, magic and life? Well, today you are going to learn how to code the game of life. Not really life, silly, but a fun game made by a super smart guy called John Conway. The fun fact is that this was A-Level 2025 Computer Science Paper 3, Section B, Programming. This was a GCE. And another fun fact is that it was also the exams I wrote. Yeah, Mr.DCT got tested with this task. We will use a computer language called C, kind of like giving instruction to your robot friend. Let's get started. I'm going to open my browser, Firefox, that's where the PDF question paper is found, and I'm going to scroll down where section B is program development, and I'll also open my IDE, Dev C++ IDE, where we're going to be doing our coding. Okay, section B, program development. Using your preferred language, your programming language, C or Pascal, and integrated programming development environment, abbreviated as IDE, carry out the following programming tasks. Note, the comments within questions start from a double slash, I hope you know that, to the end of the line, or are between forward slash and the star and forward slash. Okay, game of life description. Conway's game of life, or just life, is a cellular automation which involves life and dead cells within a grid or board, here represented as a 2D array. Grid cells are either alive or dead and evolve in successive generations as determined by their neighbors. The neighbors of any given cell are horizontal, vertical, or diagonally adjacent to it. The following rules are applied to the current or initial generation of cells in order to obtain the cell values of the next generation. Rule 1. Any live cell with fewer than 2 live neighbors dies as if caused by underpopulation. Rule 2. Any live cell with 2 or 3 live neighbors lives on to the next generation. Rule 3. Any live cell with more than 3 live neighbors dies as if by overpopulation. And Rule 4. Any dead cell with exactly 3 live neighbors becomes a live cell as if by reproduction. For example, figure 1a is a 4x4 grid for initial stage or current generation of live cellular automation, and figure 1b is the next generation obtained by obeying the above rules. So here's the representation of the stages, the initial and the next generation. Okay, I made a worksheet here. I'm going to provide a link just below the video. You are going to download it from my Google Drive. So you are going to download it and practice on how the program works. So here I said fill in the blanks, the various rules. The rule 1 was if a cell has fewer than 2 neighbors, it will die. Right? So you're going to fill it, do the rest, and just to practice before and get to know how the program works before you continue. Okay, back to our question. Task 2, coding algorithms. We develop program fragments to display and evolve successive generations of life from a 2D array. Arrays A with size, row and call, and B the same, are used to store the current and next generation of the board state. Call and row are global variables used to store the size of the arrays and are both initially set to 4. You are to develop executable code fragments and executable code from the algorithms given in each subtask. For each subtask, make sure the coding is correctly done. Okay, before we continue, I would like to define the global variables, which is row and call that they get mentioned about. So I'm going to say hash define row, set it to 4, and again hash define call, set it to 4. So they are, when you do that like this, they are already global variables. And if you look very well in my ITA, I've already commented the code throughout. Why? To ease our understanding, and also to make our video short and not too long. So, and also to guide you as we are coding along, you get to predict or get the understanding of what we are doing. Commenting codes is really necessary. Always comment your code. Okay. First part, number 1. Subprogram row line draws a horizontal line of dashes as follows. It outputs a new line, then for each column outputs 5 dashes. It then outputs a second line. Okay, that's our first task. So I commented it as function 1, row line. So since it's a function and a procedure, we're going to say void row line like this. Okay, and we want to print the dashes, right? So firstly, I'm going to print the next line for now. We're going to say print f/n for next line. So when it prints next line, we're going to print now the dashes. Best to print the dashes for the columns, we're going to use a for loop to do the traversals and print for each line. So for, let's say, int I equals to 0, I less than call, let's say column, right? So this call is going to be this for, defined as global variable. Now I plus plus. Okay, now in it we print each we print dashes, 5 dashes. So in each row we print 5 dashes, 1 2 3 4 5. After we close with a semicolon. Then after the first dash, we need to print another next line to for a good format, right? To format our code very well. So doing that, we will put /n for good formatting. Okay, and with doing that you get your 5 marks. I think that was it, because void row, yes, next line to print f, next /n for next line, and we iterate this to print for each column 5 dashes as mentioned here. Okay, let's continue. Question 2 says implement the random number generation bracket RNG given in figure 2. Here's the figure 2. Follow the directives given in it in italics. You will later call function run init with argument s in order to initialize the random code generator. Similarly, you will later call function run number repeatedly in order to return successive random numbers. Okay, so they say define the global constant run seed equals to 7. Since a global constant, we're going to do it right at the top. So I'm going to say hash define they say run seed was run seed, right? Run seed 7. Remember when you're using define, you just put equals to. There's no equals to here. Like, let me say you want to say it like this. No, it's wrong in C. That's not a good syntax. So you use, like, when you use hash define run seed, you give it a value 7 like this. You just put space and 7. Okay, continuing. We have defined the global variables with an initial default value. That means run x equals to run seed. So global variable, I already commented it. So it's going to be run seed. I'm going to give it the value of 7. The 7 is already no, I'm here. Run x, sorry, run x. I was doing it. So run x. I'm going to give it the value run seed, and run seed is 7. So like saying run x is equals to 7. Okay, and we are semicolon. Next, they say define the function run init with argument s and run a number. Okay, they commented it as seed the random number generator. RNG is for random number generator with integer s, where s less than or equals to, where s is greater than 0 and less than 16. Function run init. Okay, since doing that, I'm going to say void run init. That is random number initialized with parameter int s. Okay, init, let's say s should be between 0 and 15 because less than 16, right? So I'm going to say if s is greater than or equals to 0 and sign is like this, double ampersand in C, and s less than 16, right? We then make run x equals to s. So run x equals to s. Okay, that was it for run init. Now the next is say return the next random number. Function run init. Okay, since we are going to return a value, that means it's a function, it's not a procedure. So for procedures we don't return values, but for functions we return. So since it's a function, I'm going to be int run. We are here, right? I hope you are following up. The next function run number. So run underscore no, then no parameter for this. We are going to say run run x. Now run x was with caps. Remember they made them say, so they put lowercase here run x, and here they put uppercase run. So it need to be exactly as this one, or else you are going to have a syntax error. So capital R then an underscore x equals to bracket 5 times run x plus 3, right? Now we are following along with the pseudo code. Okay, plus mod is percentage in C, so mod 16. Alright, then we are semicolon. So run x equals to 5 times run x plus 3, then mod 16. Next is return run x. Okay, return. Now since we are using return, that's why I define the function as int. If it was a procedure, I could have put void. So int that, and return, we're going to be return rat mode this. So going to be run x, right? Mode again is percentage. Now they said mode 12 here. Normally it's not supposed to be 12. Why? Because we are going to return either 0 or 1, and since there are only 2 values, we need to use return. We need to use run x mode 2, not 12. I'm sure it was a typo here, so that the remainder, no mode will always give a remainder, so the remainder will either be 1 or 0. So mode 2, there's one correction here that I made. And I know that some people are always like confused that if I see an error during the GC, should I correct or not? For me, my own point of view, if you are really sure and you know what you are doing, you should do what is right. I can't really say anything here, but if you think anyway, you just comment below for your own point of view. Okay, we end your semicolon, and I think that's all for this figure 2 converting. Another thing is that if you really want to be good, just like advice, you really want to be good in C, in paper 3, that is computer science, in the programming section, know how to convert your pseudocodes, like study pseudocodes very well, convert many into C, because there are always going to be pseudocodes in the exam for you to convert. if you know how to convert, you are already 50% prepared. Alright, okay. Now next is question 3, or this 3 part, sub 3. It says sub-program gen cells with parameter a row called takes as argument an array A for the grid and row and call from its size. It returns a row by call but state in which each cell is randomly initialized to either alive represented by a 1 or dead represented by a 0. So alive is 1 and dead is 0 via a random number generator. Okay, I know that some of you may be confused, like what is the meaning of seed, all that stuff. If you really want to know about it, just comment below. Let me make another video about code, about random code generation in C. Or I'll just provide a link for another video you can watch. Okay, now converting this pseudocode into C, we have, since it's not returning any value, that means it's a procedure. So procedure will start with void gen cells with parameter int a, and that a will have row with size row and column. That's, yeah, it's a 2 by 2 matrix, right? Comma, then int row, comma, int call. Okay, I think the difficult part in C is not really all about. It's about like when you give it a program like maybe this Roman one, this one that you have to think of a way to code it your own. But when you know how to convert your pseudocode, you are good to go. Just need to convert all. Okay, so doing that, we have, they say for I equals to 1, they say I from 1 to row do. Okay, some people usually, there are some compilers that some people usually say that, or teach us that we should initialize our variables outside the loop, but I just prefer initializing like this inside the loop. So for int I equals to, but it's true, it's good to be in the safe side, initialize out of the loop if you are not sure of your C compiler, because old versions compilers, they tend to refuse to the format of initializing your variables out of the loop. But if you have an updated version of the your IDE, you can initialize inside the loop. I like initializing inside because it presents my code neat. Okay, so I'm going to say from I equals to 0, less than, then I less than row, comma, semicolon, I plus plus. And I know what some of you guys are saying, that why am I using 0? Well, array indexes start from 0, and either you use 1 here and you put less than or equals to sign row, or you use 0 and you just put less than row. So since array start from indexing start from 0, I like to use 0, then I put less than here. But again, you can still use 1 here and put less than or equals to. If you put 1, don't forget the equal to sign here. Okay, for that, do the inner loop for int j. Again, you can still declare your variables out of the loop. For int j equals to 0, right? J less than call, then j plus plus. Okay, now for if that is true, we said a of ij, that means a of ij equals to, that means the cell in that position ij. Just like in math, right? If you have done matrices, math or further math, when you usually index matrices, a 2 by 2 matrix, like the row and column. I stand for row, j stand for column. So in that cell number, when you insert the value rand number, and I think this rand number was with capital R, right? Remember, here they put lowercase r, but above it was capital R. so don't forget. So you end with a semicolon. Okay, and that was it. So they say end your for loop, end the second for loop, and end your subroutine or your procedure, and you get your 2 marks. Okay, moving forward, which is 4. Again, you see how I structured my work with comments. So function 4, which is simply question 4, they said subprogram count live neighbors with parameters A, R, and C. Counts the number of live neighbors in array A for the cell at row R and column C. So R and C represent row and column respectively. Okay. Here's where the logic really starts now, because this is what determines what the next generation will look like. Okay, so I'm going to say, if you look very well, it's returning a value down here called count. So I'm going to start with an int. So it's a function, not a procedure. So int count is a live neighbor. I'm sure the abbreviation. So we're going to be int A, the parameter row and call. Remember, this row and call are global variables declared up here. Okay, so comma, then int R, comma, int C for row and column respectively. Okay, after that we declare we open our curly braces for the logic in the procedure. Okay, so they say declare ij count as integers. As for me, I like to declare my variables in the loop, inside the loop, not outside. So what I'm going to do, I'm only going to declare only int, count, which is going to be the one I will use to increment down here. So since if I'm incrementing count here, it means it needs to start from 0. So I can say first int count, and I say count equals to 0, so that it starts from 0 before we start incrementing, right? Okay. Then for the I and j, we're going to be inside my loop. So for int I equals to, they say I from r minus 1 to r plus 1. So I equals to r minus 1. R minus 1. I less than or equals to r plus 1. Say I plus. Right, I hope I follow it very well. Yes. Okay. Our inner loop says for int j equals to c minus 1, j less than or equals to c plus 1. I hope I'm following very well. Yes. Then j plus to increment. Okay, in it we apply now this our logic, which says if not, that means I less than 0 or j is less than 0, or I greater than 0, greater than or equal to row, or j greater than or equal to call. Okay, applying that logic going to be if, right? If going to be if I, right, greater than or equals to 0 and I less than row, right, and bracket j greater than or equals to 0 and j less than call. If that is true, we go to the next, which says if aij equals to 1, then increment. But remember, they say here if not. So if they say if not, so we're going to say the not sign is always exclamation in C. So if not I equals to R and J equals to C, which is the column, if not this, and also A of I of ij, like this, equals 1. So we are already applying with the rules that has to be respected in order for a next generation to be generated. Okay, so if not I, which is a row, not equals to row, the R, which is row, and J, which represents the column, not equals to C, which is the column, and now A of ij not equals to 1, not equals to 1. If it is equals to 1, yes, equals to 1. For not is for I and J, if not, but for aij, we check if it's equals to 1. So if it equals to 1, well, we go to open a curly braces and we increment count. So we send that count plus, right? So and for us to increment our count, we need to make sure that it started from 0. Okay. After that, they say n if, and they say other if, n4, and the 2 4. Then after that, we return count, and with a semicolon, and after count we end our procedure here. Okay, so that was it for number 4. Let's move on to number 5. Okay, number 5, they say subprogram next gen with parameters AB generates into an array the next generation cells from array A. Okay, so again, you just need to convert the pseudocode into C. I'm going to say void. I'm using void because there's no return value, so it's a procedure. Okay, so void next gen with parameters strings A, resize row, and column. I'll just copy this and paste to save time. Comma. Then I'll change this to B. So then you put int. Okay, so okay, B, because taking two arrays A and B. So the first array is A, which is going to be the initial state, and B is going to be the next gen, which is the final state. Okay, so later we open our procedure and convert the pseudocode. So for I from 1 to row, again I'll declare my variable inside. So my I is going to be inside. For I equals to, I'm going to say use 0 again because I'll put less than row. So I equals to 0, I less than row, I plus. And again, you can still put 1 as mentioned here, then you put equal to sign. But I like to follow the way arrays works in C, right? Okay, then the next for loop says for int j equals to 0, j less than call j plus. Okay, in it now we are going to apply now this, which says n live equals to, we call the function count live neighbors. So this function count live neighbors is going to be passed inside another function. Okay, so it's like a nested function. Okay, so n live was not declared, so this is also declared it. So n live, so int n n life, right? Because to we corner this function, I'm just going to save time, count life numbers, see, okay, we paste it here. Now say count life number, we pass with the values a, comma, I, comma, j, and with a semicolon. Okay. Now after that, let's say if we are still inside the loop, right? So we are not coming out. So if a, I, j, right, equal to 1, equal to in C is double equal sign. So if you check if this equals to 1, you need to put double equal to sign. So if you put only one equal to, it's like you're assigning, you're not mostly comparing. So this equals to 1 and is double ampersand sign, and n life equal to 2, so equals to 2. Here's another logic that was going to determine the next generation. So I can say the core programs of this code that we're writing is count live neighbors and next gen. So they're going to compute the logic and determine which cells going to live or die. So let's say now to continue where we ended, so n life equal to 2 continue. Sign is just 2 vertical straight lines. N life equals to 3. Okay, then so after that we open our curly braces, then set bij equals 1. So that means we are already transferring one element from the initial gen to the next gen, which is going to be that has to go through this logic and make sure it's true. So bij, we set it to 1. Okay, and else if, so we come here, else if a of I, j equal to 0, means equal to 0, right, and n life equal 3, right, then we set bij to 1. Where am I? Bij to 1. So the same thing here, just copy and paste to save time. Always make good use of copy and paste in the exam, because there's not always going to be time to type everything. Okay, after that, else bij equals to 0. So instead of this, we simply c equals to 0. Alright, now they say n if n4 they are supposed to 2 n4. Okay, let me see something. This is our procedure. If this is our procedure, then our for loop, the second for loop, there are 2 for loops. So okay, let me see if if this is supposed to be here. Wait a bit. If we end our if, end our for, end the second for, and end the second procedure. Yes, it makes sense now. This is our procedure, the outer for, the inner for, and our if. Okay, cool. It's always good to check the format, because you can compile code and it doesn't run. So they say make sure the programs at least compile, save your work, then print your source code. Okay, moment of truth. Let's compile and see. Just they say did not say compile and run, only compile. So I only click on compile and see if there are errors. Wow, there are errors. So this was supposed to be an integer. Or what? Let me see. They say run is, so it's supposed to be an integer. Let me compile run again. Run x was it declared? It's supposed to be int also. Int. Then compile run x. So this. It says run x was not declared. So going to be an integer again. Then compile run. The errors are gradually reducing. Voila. Remember, it was capital R, not lowercase. Guys, the errors are always going to be there, just need to be okay. So here they say invalid conversion from if this is this. So what does this mean? Let me see. We have this from this ij, then ij equals to run number, and I say invalid. As you see, let me open the full screen. Invalid to int. We are supposed to declare again. Okay. Let me see if I said int that compile run. It's giving the same one. Array must be initialized with a braces digits ij equals to 1. You know what? Let's continue coding and see. At least we have only one error, line 41. I don't think this because our array is already declared inside this parameters. We just need to call it ij. So let's look at the function. That was number 3. From the function we say ij equals to run number. Oh, it was a function. So it needs to open like this. Then compile and boom, 0 errors. Okay, the reason because this was a function that I just put run number and without these parameters as if it was a normal value while it was a function. Okay, it's always good to compile your code and run as you are coding along to reduce your errors when you're doing compiling, when you are done with your work, right? So the next step is, that was number 5. Then number 6, to run our program, and we ran already with 0 errors. Now task 3 says finalizing with display. We exploit the algorithm from task 2 to display and evolve various generations of life, specifically call existing subroutines where applicable to complete each task. So 7 says in this answer booklet, exploit algorithms in task 2 to write the following. 7a subprogram print math with parameters a row call to display the board initially. So we want to display the board. Okay, and I don't really know why they why they name the procedure as print math. I mean, was it not supposed to be like print initial gen, something like that? It's always good to define your variables in a way that suits your program, right? That is meaningful. Yeah, one of the characteristics of good programming. Okay, so to do that, I think we're going to use nested for loop to print out the the initial shape, right? Okay. Going to be void print math int a row and call, right? Row call. Okay, then comma int row comma int call, open and curly braces. Now we need to print now the shape for the initial shape. Okay, how are we going to do that? So we need a nested for loop. Let me see. If you continue down, number 8 says, so normally you are supposed to write this in your answer sheet, right? But I'm going to be doing directly my IGE, because if you read down here in number 8, they said in your IGE develop the executable program from the algorithms in question 7. So you are converting all of this into your IGE. So I'm already answering this question in my IGE, and that's already number 8. So they say executable program from your algorithm in 7. Your program should display a vertical bar. Okay, we're going to need a vertical bar, an appropriate number of spaces before each value printed. Okay, vertical bar and a space for good formatting, and a final bar at the end of the row. Use subprogram row line to draw lines between rows. Okay, your grid layout should be similar to those in figure 1. Let's go down to figure 1. Okay, so our display should look something like this. Okay, with the vertical bar and the horizontal dashes that was initially made here in row line. So we are going to call that function inside our function, nested functions. Okay, so doing that, okay, I'm going to first start defining while I already declared it. So for int I I equals to 0, I less than row I plus plus, right? I'm going to print the rows. So to print the dashes in the first row, I'm going to call the function row line, right? So to draw this line, I'm going to call this function. Okay, so I'm going to call the function right down here. I'm going to draw the line for me, the dashes for me, and after that I need the second for loop. So after I draw the row, in my second for loop for int j equals to 0, j less than call j plus plus to increment. Okay, so in it I need to print now, print f. So they say print a vertical bar. So I'm going to print a vertical bar. Okay. It says with appropriate number of spaces, I'll put 1, 2 spaces, and %d for the value for the next gen, for the initial gen. So the value in the initial gen, then another space, after that comma, and going to be a of initial gen, a of ij, okay, ij. So it's going to print initially the element that is found in here in position ij. Okay, after that I'm going to go to the next line. Yes, let me print f percentage /n for next line, semicolon. Okay, and after that now I'm going to print again, call again this function to print the dashes, because after the next line you need to print again, and the function repeatedly does its work. Okay, I hope everything is correct. Let me verify. Print one this. The first for loop will print the dashes. The second for loop we're going to access now the position of the array, then print now the value in it, either 0 or 1 for live or dead. Okay, after print percentage, I will print for next line. I don't know, do we need another next line maybe at the beginning? Anyway, we'll compile our code and do some adjustment as we go along. Okay, so we need again 7b subprogram print next gen with parameters b row code to display the box next gen. Okay, so we look at where it's similar to this a part. To save time, I'll just copy and paste and just change the names, right? Control C is the same code. So instead of print max here, we're going to be print next gen. Print next, right? Print next gen. Okay, print next gen with parameter p as a and row code. Okay, for in this we'll do the same thing. Then here instead of a we put b. Okay, I think that is all. I don't know whether we need a printf statement here too for good formatting. Printf and next line for good formatting. Yeah, let me, because our output needs to resemble this. I think we need to first of all go to the next line after we print the row, the next line. Anyway, we'll test ahead as we go along. Okay, doing that, we are done with 7a and b. Okay, the 9th part says, which is already our main function, write a main program that calls the following subprogram in order to print and evolve the cellular automation. So we call the function excuse me, we call the function run init, gen cells, print math, next gen, and print next gen. Okay, they say note, see figure 2 for constraints on argument s in function run init. What are you talking about? Let's go to function figure 2. Okay, this figure 2, they say on run init. Okay, with argument s. So they are given for us to use this argument, we are going to pass it in the main function. So maybe we are going to ask the user to enter a random the seed, right? Because this s is the seed. But let the seed be between 0 to 15, right? So the user is going to enter this and we are going to pass it in this function. Okay, so that's the constraint. Okay, so before that, we need to first of all define the various arrays that we use. And for b, copy and paste to save time. Okay, semicolon. Now in s, which is the seed that the user is going to enter. Okay, so step 1, we said seed the RNG, which is random number generator. So we need to first of all call this function RNG. Before that, we need to again need the user to enter the seed, right? So /n for next line, I'll say enter the seed, and to make the user know that it's between 0 to 15, because it says s greater than 0 and less than 16, so it should be 15. Okay, then /n for for next line good formatting. Okay, then scan F, percentage D, ampersand S. So the user is going to enter the seed, and after taking the seed, we are going to pass it through the function run init. So this run init, where is it? Here is it. Okay, we're going to pass in here. So the S value is going to be entered by the user, and when it's passed in here, you don't need to declare again because we have declared up here. So when it takes the value, it passes through this the parameter run init, and for processing right up. Okay, that's all for the seed. Now they say gen cells. Okay, generate initial bot. So you just have to call the function gen cells, right? Okay, gen cells is going to be called here, but the parameters are going to be here. They said gen cells a row call. Okay, so it's going to be a comma row comma call, like this, right? Okay, hope I'm doing correctly. Voila, these rows are going to be global rows, because if I say row, this other row, if I put only there's an error here, because if I put only lowercase I, the program is going to be like, where is this? It will be like this. This one with lowercase will be like, the program will be like, where is call come from? Like, you didn't declare it in the main function and you're using it here. So if you use the capital C, you're going to know that it's a global variable which was already declared up here. So another mistake, don't use lowercase. If you use lowercase, you have to define it again, initialize it again in the main function, give it a value before you use it. But if you use it like this, it's going to be a general, so it's a global constant. I hope you get the point. Now the next is print math. So we need to print the initial generation. But to print that, I would like to tell the user that this is the initial generation. So I'll say initial generation, right? /n for good formatting. Then after that, I can now call another function initial gen, which is print math. Where's that print math? Okay, Control C. Okay, is the value a does not is row of call. Again, this row is supposed to be the global constant, the global variable, right? Cool. Now step 4, which is next gen, which we need to compute now the generation. Yes, this is next gen. Parameters A and B. So next gen, the parameters A and B. I'm using A and B already without declaring because I've declared already at the top here, right? A and B. So without declaring, then use semicolon. Don't forget also a semicolon at the top here. Always end your C statement with semicolon. And finally, print next gen. So print next gen is the final procedure to be called, or function to be called, whatsoever how you call it. Okay, we're going to be called with capital C, then row, capital R, then I'm trying to save time by not typing. Okay, end with your semicolon. I think that's all about the code. The same, print a copy of your entire source code. Okay, number 11. The first one, let's compile run and see the errors. Compile. Oh, there are errors. So, like it's here, they say printf name lookup for I change for iOS for scoping. What does that mean now? So I is I less than this, I plus plus, then printf percentage G of ij. What's the problem? Printf percentage G ij. Okay, again they said if use what we accept. I really have no idea what they're talking about. Okay, they say name lookup use this for I. So what do they mean? Okay, don't worry, it's the normal that they are always going to have errors. So compare again. I printf reduce ij. It's supposed to be print what is found in percentage ij, and let me see. This loop is supposed to be inside. Get the point? Because we are using I, so it should be somewhere. What should I put it? Somewhere like this. Alright, so this ij, let me see. When I'm using ij, it's mentioning so that this for loop is inside the other outer loop. You get the point? Let me compare and see. B the same, the same error. So alright, this was supposed to be in here. Okay. Okay, let's compare and run again. Wow, it is running. Okay, let's enter our seat. Let me say 7. Boom. Our program runs, but is it good? Voila. It's printing initial generation after this, but it's not printed after because we do not use a printf statement before printing the next generation. So we can say printf control C to copy, then paste here for good formatting, right? To make sure you're good. So going to be next generation. Okay, I think I could work now perfectly. Boom. Okay, let me enter the seat at 7. Boom, work correctly. 4x4 matrix. 1 2 3 4 1 2 3 4. Okay, so this is the initial generation and the next generation. Now continuing, they said 11, modify your program from task 3 8 here, right, so that the row and column dimensions of the pod is 8. Make sure the program works correctly, then run it and screenshot its initial and next generation stages. Save them in the file called size 8 output, and then print your copy. How you know how to say, right? So to do that, since we were using our global variables, it will be easy. Just scroll right at the top and change our row to 8. Change column the same to 8. And if you compare and run, it should give you a bigger square. Okay, so if I enter 7, you can enter any seat. Boom, you see, it's now an 8x8 matrix. Okay, it was fun. I think that was it, right? Okay, Okay guys, you did it. Boom. You built your own wall and watch it evolve with your smart code, right? For more, join DCT Lab for more coding adventures. Don't forget to like, share, subscribe, and comment your favorite part. More fun coding adventures coming soon with Mr. DCT. Bye bye.